Hi everyone, welcome to today's class. Today we will start second lesson of our physics textbook, electric potential and capacitance. Today we will be discussing electric potential and potential difference. You know the meaning of the term potential. What is the meaning of potential? I am telling you have lot of potential. What is the meaning? You have some ability, right? You can do something, you can do some work. That's the meaning of you have some potential. Previous lesson, we learned electric charges, electric fields, and forces. You know an idea of electric field. Okay. So a charge can do work in an electric field. So we are going to learn the topic electric potential. You imagine a positive charge. If you bring another charge, another positive charge towards it, you feel more opposition. As you come towards the charge, you experience more repulsive force. So you have to do work against it. Okay. When you approaches the positive, if you bring another charge to a positive charge, you need to do more work as the charges become closer and closer. So you have to do work. This work done is stored in the charge which you are moving as it's a potential energy. Okay. Now we are going to define potential at a point in an electric field. Electric potential at a point in an electric field. So today we will discuss electric potential at a point. Imagine a positive charge. This is a positive charge. I name it as Q. You know, surrounding the charge, electric field is there. So you know what is electric field? It is a region around a charge where another charge can experience force. So around this charge is the electric field is there. And electric field is zero at infinity. Electric field is zero at infinite distance from the charge Q. Okay. So if you move a charge, another charge from infinity towards this charge, okay, this charge I consider positive charge. So you are moving another charge. That charge I call as test charge towards it. That also positive charge. So repulsive force increases as you come closer. So you need to do work done by you, that you are an external agency. Okay. So this work done is stored as potential energy of the charge. So imagine a point P. Okay. That is at a distance R from the charge Q. This charge Q is called source charge. I name it as A. The charge placed at the point A is the source charge. we are moving another charge from infinity to the point P. That charge is known as test charge. Electric potential at this point is defined as the work done to move a unit to positive charge. Remember, unit to positive charge, 1 coulomb charge from infinity to this particular point. That's the definition for electric potential. But this unit to charge must be moved with the constant speed. There should not be acceleration. Okay. So what is the definition for electric potential at a point? Electrostatic potential at a point in an electric field is defined as the amount of work done to bring a unit to positive charge from infinity to the point P without acceleration. Okay, so we can define potential as work per charge, work per unit charge, Q0, W by Q0. Q0 is known as the test charge. Okay, so why we have to move from infinity? Because at infinity, force due to the source charge is 0. So this is a definition for electric potential. I repeat again the definition for the electrostatic potential. It is the amount of work done to move a unit to positive charge. Unit to positive charge is 1 coulomb charge from infinity to the particular point. The equation for potential is V is equal to W by Q0. What is this Q0? Test charge. W is the work done. So electric potential at a point in an electric field is defined as the amount of work done to move a unit to positive charge from infinity to that particular point without acceleration. So I will write the definition here. All of you note down. Electric potential at a point in an electric field is defined as the amount of work done to move a unit positive charge from infinity to the point without acceleration against the electric field. This is a definition for electrostatic potential. Okay. What is the unit of potential? SI unit. You know, V is W by Q. Work, you know the unit, joule. Joule per coulomb. Charge unit is coulomb. This is known as volt. Okay. So unit of potential difference is volt. If you are moving 1 coulomb with positive charge from infinity to the point P, and if you are doing 1 joule of work, then potential at the point is 1 volt. And one thing you have to remember, as you are coming closer to a positive, potential increase. As you are moving closer, as you are moving a unit to positive charge, towards the charge, source charge, potential increases. So towards a positive charge, potential increase. If you move away from a positive charge, potential due to it decrease. In the same way, if you move towards a negative charge, potential due to it will decrease. If you move away from a negative charge, potential due to it increase. So this is the equation for the potential difference at a, this is the equation for the potential at a point. Now we are coming to potential difference between 2 points. What is a potential difference between 2 points? Here we have to move a charge in between these 2 points. So potential difference between 2 points is the amount of work done to move unit to positive charge from one point to another point. Suppose we are moving the charge from a point B to A. So potential difference between these 2 points is the amount of work done to move 1 coulomb charge from the point A to B. So again, consider this is a source charge. This point is A. This point is B. Suppose we move unit to positive charge from B to A. Then the work done to move the charge from B to A is known as potential difference between the point A and B. See, we denote as VA minus VB. Potential difference between 2 points is defined as the amount of work done to move a unit positive charge. That means 1 coulomb charge between these 2 points without acceleration. Suppose we are moving a charge from B to A. So PD between the points A and B is potential difference between the points A and B is VA minus VB. So here we are moving 1 coulomb charge from B to A. This is the potential difference between 2 points. We write it as VAB. That is equal to VA minus VB. Okay. Now, what is the definition for? So we learned the definition for potential. What is this potential energy? In the beginning, I discussed if you want to move a charge in an electrostatic field, we have to do work. Okay, that work done by the external agency is stored in the charge as its potential energy. So potential energy of a charge is the work done to move that charge in the electric field without acceleration. That is the potential energy of that charge. Okay. If I call potential means it is a work done to move 1 coulomb positive charge from infinity to the particular point without acceleration. Now we can derive the relation between potential difference and electric field. See, the electric field and potential difference related. Let us derive the equation for relation between potential difference and electric field. So this is a small derivation and it is very important. The relation between potential difference and writing PD and the electric field. Potential difference we can take as dV. So we consider a charge Q here. This is a positive charge. Okay. Imagine a point P. Point P. Here, you know, electric field due to the source charge is directed away. Electric field direction is in this way. And I am moving the charge from this point B to A. So I am moving a small charge, delta Q. So test charge, I am placing a test charge delta Q. If suppose I move a test charge delta Q from B to A. So when you are moving B to A, displacement dr is the displacement. Suppose dr is the displacement. See, electric field and dr are opposite. We are moving the charge against the electric field. Now you can calculate the work done for this. Work done to move a small charge dq from B to A. Or we consider work done to move the charge dq through a small distance, dr. Through a small distance. A small distance, dr is, you know the equation for work done. What is the equation for work done? F dot dr. 11th standard we learned. So the work done, we write dw is F dot dr. So we can write this F as, you know, electric field equation, you know, F by dq. So what is electric field then? Force then delta Q into E. So we substitute this F dot dr, you can write F dr cos theta. So here we move the charge opposite to the electric field direction. So cos 180 will come. Cos 180. And you know cos 180 is -1. So F dr. Now you can write the equation for F. dq into E into dr. Okay. Then you can rearrange this as dw by dq equals minus EDR. Okay. And you know, you learned work done per unit charge. dw by dq means work done per unit charge. That is known as change in potential. dw is the change in work for moving a small charge dq. So dw by dq is known as potential difference, dv. So dv equals minus EDR. Okay. So this is the potential difference. E is equal to minus dV equals minus dr. So we can write here E equals minus dV by dr. So this is the relation between electric field and potential. Electric field and potential. What is the relation, children? E is equal to minus dV by dr. Minus dV by dr. So electric field is the negative gradient of electric potential. V is known as potential. So electric field is the negative gradient of electric potential. Okay. Electric field is known as negative. Electric field is the negative gradient of electric potential. Okay. We can write V in another. If you integrate dV, we are moving from B to A. So if you are integrating between A and B, so dV equals minus EdR. Since we moved the charge from B to A, you are integrating it from integral dV. So what is integral dV? Minus of integral EdR. Okay. Integral dV is V only, right? Therefore, we can write integral dV is V. V is equal to minus integral EdR. Since we move from B to A, this is the potential difference between A and B. Okay. So this relation you remember. E is equal to minus dV by dr. So what is the relation between electric field and potential difference? Electric field is the negative gradient of electric potential. Okay. Electric field is the negative gradient of electric potential. Remember. And you see this equation. In this, we can make two conclusions from this equation. E is equal to minus dV by dr. First conclusion is electric field is the negative gradient of, so you write as a note. Electric field is the negative gradient of electric potential. And there is a negative sign there. What is the importance of the negative sign? This negative sign shows that electric field is in the direction of decreasing potential. If you move in the direction of electric field, potential decrease. That is the meaning. So a negative sign shows that as we move in the direction of electric field, potential decreases. Potential decreases. So far what we learned, we defined electric potential at a point. What is the electric potential at a point? It is the amount of work done to move a unit positive charge from infinity to the particular point without acceleration against the direction of electric field. Okay, and we got the equation electric potential is W by Q, work done divided by the charge. And we learned potential difference. What is potential difference between 2 points? It is the amount of work done to move a unit to positive charge between 2 points without acceleration. Okay, if we move a charge from the point B to A, the potential difference between 2 points we take as VAB. It is equal to VA minus VB. And we obtained the relation between potential difference and the electric field. What is a relation? Electric field is the negative gradient of electric potential. Okay. And what is the importance of the negative sign? The negative sign shows that if we move in the direction of electric field, potential decreases steepest. These points you have to remember. Okay, children? Now, when you move towards a positive charge, what will happen to the potential? Increase. Okay. When you move towards a negative charge, what will happen to the potential? Decrease. Potential due to that charge will decrease. Okay. So what is the meaning of potential energy of a charge? When you move a charge in an electric field, you have to do work. External work must be done. This external work done is stored in the form of potential energy in that charge. So what is the potential energy of a charge? It is the amount of work done by an external agency to move that charge in the electric field. Okay, children. So we will stop today's class. Thank you for watching.